Good morning. Here is the second video covering lessons 9.2 and 9.3. Okay, today we're going to talk about exponential functions. Exponential functions. The formula for exponential function is y equals ab to the x. Okay, y equals ab to the x. That is the formula, okay, for an exponential function. An exponential function, okay, has an independent variable as the exponent. Here's examples. Y equals 3 to the x, y equals negative 2 times 0.5 to the x. They're exponential functions. See? Y equals a, b to the x. Y equals a, there's no a there, b to the x. A set of ordered pairs satisfies an exponential function if the y values are multiplied. So the key, okay, if something is exponential or not, is if the y values are multiplied. That is the key. So the question is, are the y values multiplied? Your x's have to be constant, 3, 5, 7, 9, that's good. Are the y values multiplied? 4, 12, 36, 108, yes they are. They are exponential because they're multiplied by 3. The x values increase by a constant amount 2. The y values are multiplied by 3, therefore it's exponential. Okay, if we look at this one, is this exponential, yes or no? My x's are good. Look at my y's, 2, 4, 6, 8. Are those multiplied? No. Therefore, not exponential. Okay, so that's our first part. Is it exponential or is it not? Okay, second example. Population of a school can be described by the function f of x equals 1500 times 1.02 to the x, where x represents the number of years since the school was built. What will the population be in 12 years? Now, this is a different type of problem than what we learned last lesson, which said geometric. Okay, the key word there was geometric. So here, they want to know what the population is going to be in 12 years. All you have to do is plug in 12 for x, because what does x say? X represents the number of years, 12 years. So all you do is plug in 12 for x. So let's take our handy-dandy calculator and let's plug in. Okay, so we're taking 12 for x. So remember, we got to use our y to the x button right, let me move this up, right up here. Okay, so 1.02 y to the x, 12 equals, okay, times 1500 equals. Now, notice we get this answer. What are we talking about here? We're talking about population. When we talk about people, we have to round to the nearest whole. So we're going to use our rounding rules. You get 1902.3, or 0.4 rather, okay? So you round to the nearest whole number, which is 1902. Okay? All right, so let's practice. So does it satisfy an exponential function? Yes or no? Okay. So x's are good. 1.53, 6, 12. Yes, because it multiplies by 2. Okay, number 2. 1, 2, 3, 4 is good. 1, 2, 6, 24. Is that multiplied? Are my y's being multiplied? And the answer is no. This is multiplied by 2. This is multiplied by 3. This is multiplied by 4. So therefore it's no. Number 3, is this being multiplied? My x's are good. They're constant. My y's, negative 2, negative 10, negative 50, negative 250. And the answer is yes, it's being multiplied by 5. Okay, so you're going to have to know problems like that. Okay, next. If a rubber ball is dropped from a height of 10 feet, the function, here's my function, gives the height in feet of each bounce, where x is the bounce number. X is the bounce number. What's the height of the 5th bounce? Okay, so we have to show our work, and we let the calculator do the work for us. We write out our problem. F of x equals 20 times 0.6 to the x. What's x? X is 5. See, x is the bounce number, and it's the 5th bounce. Okay, so how are we showing that? Okay, how are we going to show that? 0.6 y to the x, 5 equals times 20 equals. Okay, now look at my answer. 1.5552. Okay? That's not my answer. What does it say? It says, first of all, it says round to the nearest tenth of a foot. Nearest tenth. So nearest tenth would be 1.6. Okay, got to follow directions. All right, population of pigs expected to increase at a rate of 4% each. The original population is 1,000. There's your function. Gives the population in X years. X years, what's the population in 12 years? 1,000 times 1.04 to the 12. Okay, and what are we talking about here? Population of pigs. So if it's pigs, okay, has to be to the nearest whole. Nearest whole. 1.04 y to the x, 12 equals times 1,000. Now, here's what we get. We get 1601.03. Okay, well, you need the nearest whole pig. So we get 1601. Okay? So those are the two things we've done so far. Okay, on the back. On the back, we're going to talk about graphing, a little bit of graphing. Okay, what's really important is that the graph of an exponential function is always in two quadrants. Is always in two quadrants. Okay, now I know these aren't the best of graphs, but if you look closely, okay, maybe we can highlight here with different colors. The graphs go in two quadrants. This one starts here and comes down, and it comes really close to the x-axis, doesn't touch. Okay, this one's here. It's really close to the x-axis. I know it looks like it touches, but it doesn't. Really close. Okay, see, every time it goes in two quadrants. Okay. So again, formula is y equals ab to the x. So we're going to graph this. Now, the x values will be given to you because you want it to make a nice smooth curve. See how it makes a smooth curve? Every time it curves. Okay? So we're going to create a table of ordered pairs. All right, I plug in -1 for x. So where's -1 going? In for x right there. Okay, so notice 2 to the -1. Oh, any number to a negative exponent is a fraction. Hope we remember that. So 2 to the -1 is 1 over 2. 1 over 2 times -3 is -1.5. So we plot -1, -1.5. And again, I know these are not the best of graphs, even with my glasses on. I'm having a little trouble. Any number to the 0 power is 1. 1 times -3 is -3. 0, -3. Two to the 1 is 2 times -3 is -6. 1, -6. See how it's making a curve. 2 to the 2 is 4 times -3 is -12. So 2, -12. and there's my curve. There's my smooth curve. Okay, so we'll try a couple of these. Okay. We're going to do number 7 first. We'll start with number 7 first. Okay, we're going to plug in -1. 5 to the -1 is 1/5. 1/5 times 2 is 2/5. 5 to the 0 is 1. 1 times 2 is 2. 5 to the 1 is 5 times 2 is 10. 5 to the 2 is 25 times 2 is 50. Okay, and we're going to plot this. -1, 2/5. So here's -1, 2/5. Right there. 0, 2. So it's kind of next to it, just a little bit up more. 1 and 10. And then 2 and 50. And notice it makes a smooth curve. And I'm sorry, these are not the best graphs. Goes very close to the x-axis, but doesn't quite touch it. And you can see the 4 dots. Okay, let's do number 8, and then we'll go back to number 6. Okay, -1 times 2 to the -1. 2 to the -1, fraction, 1/2. 1/2 times -1 is -1/2. 2 to the 0 is 1. 1 times -1 is -1. 2 to the 1 is 2. 2 times -1 is -2. 2 to the 2 is 4 times -1 is -4. So -1, -1/2. -1, -1/2. Right there. 0, -1. 1, -2. And 2, -4. Again, you can see the smooth curve. If your line goes into, let's say, this quadrant, that means I went into 3 quadrants. Okay, I can only go into 2 quadrants. Only go into 2 quadrants. And there we have 9.2. Okay, moving on to 9.3. 9.3 is about exponential growth and decay. Exponential growth and decay. Our first formula that you have to memorize is exponential growth. Okay, here's your formula for exponential growth that you need to memorize. Okay, whereas y is the amount, a is your original amount, okay? R stands for the rate of growth, and T stands for time. The population in a city is increasing at a rate of 4%. In 2000, there were 236,000 people in the city. Write an exponential growth function to model this situation, then find the population. Okay, well, here's what we know. We're trying to find our answer, which is y. And we're trying to first write a model. Okay, so A is the amount. What's the amount here? 236,000. Okay. 236,000 times the rate. The rate is 4%. So we're talking to go from percent to decimal, you have to move it 2 spaces to the left. So to go from percent to decimal is 2 spaces to the left. Okay, why do we say 2 spaces? Because it means 100. So 100 has 2 zeros, 2 spaces. So 2 spaces to the left. All right, in this case, 4% is 0.04. So 1.04 to the t. That's the model. Okay? You could write 1 plus 04 like they have here. That's fine. Okay? Or you can just write 1.04 to the t. Okay, that's the model. Now it asks for what's the population in 2009. Well, it's starting in 2000 to 2009. Well, now we're plugging it into the 9. So here's your work. 236,000 times 1.04 to the 9. Well, it's the same thing. We use our calculator. 1.04 y to the x 9 equals times 236,000 equals. Okay, and what are we talking about here? When we're talking about population, we're talking people, nearest whole number, use your rounding rules. That says 335,901.5 or 0.6 rather. That means you round up to 335,902. Okay. So we're going to write an exponential growth function. What words mean exponential growth? Increase. Okay, that's another word for exponential growth. Okay, annual sales company or 372,000, increasing at a rate of 5% per year for 8 years. 372,000. 5%, 1 plus 0.05 to the 8. Okay, and we get as our answer, when we do it on the calculator, you should get 549,600, can we see this? No. $613.43. Okay, you can write it as 1 plus 0.05, or we can write it as 1.05, okay? Either one, same thing. Okay, now when we're talking money, money is the nearest penny. Money is the nearest penny. Population or people is the nearest whole. Okay, any questions on that? Okay, and here's your answer. Okay, number 2. The population of a town is increasing at a rate of 3% per year for 7 years. So y equals 4,200 times 3%, 1.03 to the 7. Okay, and we get, when we do it on the calculator, 5165.4. But we're talking about population, we're talking about people, it's the nearest whole number, so therefore it's 5165. That is your final answer. Gotta know what you're talking about, guys. Okay, and that's exponential growth. Notice your keywords: increasing, increasing. Okay, exponential decay, same thing, but now we're decreasing. Exponential decay. Okay, so going back to the formula up here, exponential decay is 1 minus r to the t. Okay, there's your exponential decay, 1 minus r. So here, 6%. So the model would be y equals 35,000 now 6%, so you're subtracting. You are subtracting from 100. So 100 minus 6 is 94. Put a decimal in front. You can do it like that, 0.94, or 1 minus 0.06 to the t. That's for writing a model. If it says write out the model, see how it says write an exponential decay function to model the situation. That's modeling the situation. Now, Now find the population in 2012. 0.94 to the, what number am I putting up here? Well, I'm starting in 2000 and I'm going to 2012, therefore it's to the 12. And when I do it on the calculator, I get 16,657. And we're talking about population, so it's people. Okay, keyword for decay would be decrease. It's decreasing. Okay. Now let's go back to here. Okay, monthly car sales for a certain type of car, 350,000, and are decreasing at a rate of 3% per month for 6 months. Okay, so 350,000. 1 minus, so 0.03 to the 6. Okay, you can write 1 minus 0.03 or you can put 0.97. Same thing. Okay, and you do it on the calculator and you get 291,540 and you get 0.2. Well, what does 0.2 mean? That means 20 cents. Okay. And lastly, an internet chat room has 1,200 participants and is decreasing at a rate of 2% per year for 5 years. 1,200 decreasing. Okay, 1 minus, which is 0.98 to the 5. And you get 1084.7, which is 1,085 people. Okay, don't take my word for it. You should be checking yourself on the calculator, making sure this is right. Okay, so that's 2 formulas. We have 1 more to learn on the back, and then we'll be done. Last formula. It's called compound interest. Okay, so with compound interest, here is your formula. Okay, here is your formula right here. Okay, let me explain what everything stands for. A is the total balance. P is the amount. R is your rate. N is the number of times the interest is compounded in 1 year. And T is the number of years. So when I say compounded, it could be compounded annually, which means 1, quarterly, which means 4, monthly, which means 12. Those are the basic ones. So if you look over here, a compound interest function is to model compound interest function to model 15,000. Okay, 15,000, that's your P. Invested at a rate of 3%, there's your rate, 0.03. Compounded quarterly. Quarterly, which is your N. That means 4. So I got to put the N here and the N here. Find the balance after 8 years, and you put your T here. Okay, so let's do this on the calculator, and do this with me, please. First thing I'm going to do, 0.03 divided by 4. 0.03 divided by 4 equals. Then add 1, plus 1 equals. We should get 1.0075. Then y to the x, 32, because you have to do the NT. Y to the x, 32 equals, finally, times 15,000 equals. And I get 19,051.67. 668, 67. We're talking money, rounds the nearest penny. Okay, let's try these last 2 problems using this formula. All right, write a compound interest function to model the situation. 17,000 invested at 3% compounded annually for 6 years. Okay, so here we go. Okay, 3%, compounded annually. Annually means 1. Okay, so A equals 17,000 times, okay, 1 plus my rate, 3%, 0.03. My N annually, 1, times NT. N is 1, T is 6. There's my T. And that's how it should be set up. Okay, we do the math. 0.03 divided by 1. I get 0.03 plus 1. 0.03 divided by 1 equals, plus 1 equals. Okay? Y to the x, 6 equals, times 17,000 equals. Final answer? Okay, talking money. $20,298.89. That's your answer. Okay, last problem. 23,000 invested at 2%, that's my rate. Compounded quarterly, that means 4 for 8 years. So A equals 23,000. 1 plus my rate, 0.02. My N is 4 to the N and T. Okay, we set it up, and when we get our answer, we should be getting this answer when you do it. $26,979.99. And that's how we do these problems. You'll have another My HRW, and this My HRW is due Monday. Good luck, guys, and I'm sorry these videos are long, but I really hope you're taking the time to learn them. Oops.